Hey, well, good afternoon. This is a video to walk you through the solutions to the second midterm exam. So the first couple questions are actually related. So a strong acid is also what you would call a strong electrolyte. You can really say those terms are synonymous. And so the first question is talking about weak, non, or strong electrolytes. And also acids is on here too. So it's worthwhile saying for both of these questions, as I said in lecture, if it's not one of these six, so nitric, sulfuric, perchloric, and then you've got HCl, HBr, and HI. If it's not one of these six, then you consider that it's weak. So these are the only, for this class, these are the only strong acids. So that one, that one, that one aren't on this list, so they're considered weak. Okay? And these ones, so they're not all acids either, because these are weak bases. Okay, so remember the strong bases are, if you have a group 1 or 2, hydroxide. Okay, and the only exception is beryllium, but all the others like lithium hydroxide, calcium hydroxide, all those are strong. And then anything else, again, you consider that they are weak. Okay, and so for question 2, this isn't on that list of 6, so that's also a weak acid, so that's a false statement. Okay. All right, so our first calculation here is a limiting reagent question. And so 5 grams of iron reacts with 5 grams of water. Okay, and you want to make sure that it's balanced. And that looks like it is, just to verify. Yep, it is balanced. Okay, and so if you have grams, you should calculate moles. And so let's divide by the atomic or molar masses here. So iron is 55.85. And water is 18 grams per mole. Okay, so iron, you have 5 divided by 55.85, you get 0.0895 moles. And then the other one, 5 divided by 18, you have 0.2778 moles. Okay, so you can't directly compare these because these numbers are not the same. Okay, so to directly compare, we have to do apples-apples comparison, so on like a molar basis. And so let's divide this one by 3, and then this one, let's divide it by 4. Okay, and then we'll compare. So 0.2778 divided by 4 is 0.0694 moles, and then the other one divided by 3 is 0.0298 moles. Okay, so now you look at which is smaller. It's this, which is iron. So that means that iron is the limiting reagent. Okay, and so that's as far as you really need to get in these questions here. So this says water is the limiting reagent, and so the question here is which one is false. Okay, and so that is wrong because iron is the limiting reagent. Okay, this is the smallest number after you are comparing moles to moles. Okay. The next question, you have 4.691 grams of magnesium chloride, and the total volume is 750 mils. Okay, so it's asking concentration, so that means capital M, okay, which is moles of solute divided by liters of solution. Okay, so we have to get moles, and so we have to do 4.691 grams divided by its molar mass. And so magnesium is 24.305, and then chlorine 35.45. And we have two of them. So that's a total of oops, you can't see that. 95.205 grams per mole. Okay, so you do 4.691 divided by that. So you have 0.0493 moles, and then you have to do it per liter, so that's 0.750 liters, right? Just the simple conversion. Okay, and so if you do that, divided by 0.75, you will get 0.0657 moles per liter, okay, which is that answer there in scientific notation. Okay, this next one, diluted, so that means it's M1V1, M2V2. Okay, so you've got 0.436 concentration times 50 mils. Okay, and you don't have to, for this equation, you don't have to convert all the volumes to liters, just as long as both sides of the equal sign has the same unit. Okay, and we want to know what's the concentration of the resulting solution. So we're going to solve for M2. And then V2 is total volume of 250 mils. Okay, so essentially we're just dividing both sides by 250. Okay, so then M2 is 0.436 times 50 divided by 250. That gives you 0.0872. And the unit is capital M. Okay, this next one is just asking about balancing. So calcium phosphate, calcium forms that ion. Phosphate, remember, is that. Okay, so that means its formula is going to be this. Okay, that's calcium phosphate. So it's Ca3PO42, and it reacts with sulfuric acid to give you calcium sulfate, because sulfate is this guy, okay, and phosphoric acid. Okay, so to balance this, I would keep all of these complex anions together, actually, when you're balancing. And so I would do maybe calcium first, then I would do the phosphates. So you need a 2 in front of there. And then the sulfates, so you need a 3 there. Okay, so I think that should be balanced. Yep. And so it's asking, what is the coefficient for sulfuric acid? And so that is 3. Okay. This next one, dinitrogen monoxide, decomposes to form nitrogen gas and oxygen gas. Remember, these are diatomic elements. So it's not just N and O, it's N2 and O2. Okay? So I think that's gas also. So we have to balance this first. So that would be a 2 there, 2 there. Okay, and now you're doing 5 grams of that. And how many grams of oxygen are formed? Okay, so this we have to convert to moles, and so we need the molar mass of N2O. So nitrogen is 14. We have 2 of them, and then oxygen is 16. So that's 44 grams per mole. Okay, so 5 divided by 44 gives you 0.114 moles of N2O. Okay, so now we want to know moles of oxygen. And so you have a 2, whoops, you can't see any of that, oops, sorry. So we had the molar mass there, and so I just did 5 divided by 44, and that gave you moles of nitrous oxide. And so now you want to convert to moles of oxygen. So we are going to look for the ratio. So it's 2 to 1. And so we are going to have to divide by 2. Or in other words, we're going to have to multiply by 1/2. Okay, so again, with what's on top, what's on bottom, what you're going to is on the top. What you're coming from is on the bottom. Okay, if you look at it that way. Okay, so 0.114 divided by 2, or times 1/2, gives you 0.0568 moles. Okay, and then it's asking for grams, so we're going to have to multiply by this molar mass for oxygen. And so that's 32 grams per mole. So 2 oxygen atoms, each are 16. And so 32 times that will give you 1.82 grams. Okay. How many anions are in that many grams of magnesium bromide? When you see how many in a question, think of Avogadro's number. Okay, so it's going to be this insanely large number. Okay, and so 0.5 grams of magnesium bromide, we have to first get moles. Okay, so remember, where can I write it? Like here. So we had moles, number, and then grams. If we are moving out of moles, we're multiplying by something. And to get back to moles, we're dividing. Okay, so between grams and moles here, this is molar mass. Between here, this is Avogadro's number. So we have grams. We have to first divide by the molar mass to get moles. Then we multiply by Avogadro's number to give you the number of something. Okay. So 0.5 grams, we have to get the molar mass of magnesium bromide. So magnesium is 24.305, and then each bromine 79.904, and you have 2 of them. So that's 184.113 grams per mole. So 0.5 divided by gives you 0.00272 moles of magnesium bromide. Okay, and then let's multiply by Avogadro's number. So that gives you 1.63 times 10 to the 21 mgBr2 formula units. It's not really a molecule, but you have this many of these compounds, okay? But it's asking for just the anions. Okay, oops, again, I didn't switch back. Whoops, sorry. Okay, so I have 0.5, the grams you were given, divided by the molar mass of magnesium bromide, and that gave you 0.00272 moles. You multiply by Avogadro's number, and this is what you get for this whole compound. So this is how many of these whole compounds you have. It's asking just how many anions. And so do you see that there are 2 bromides for every one of these whole compounds? So you just have to multiply this by 2. Okay, or in other words, this breaks apart into that and 2 bromides, right? So you have to multiply by 2. And so that times 2 gives you the answer that is selected there. So 3.27 times 10 to the 21 bromide ions. Okay. How many grams of silver nitrate needed to make that solution? Okay, so this If you see a concentration and a volume together, that tells you you can get moles out of it. So it's 0.135 moles per liter, and then you just multiply by 0.250 liters, which is 250 mils. Okay, and so when you do that, 0.135, 0.25, you get 0.03375 moles. Okay, it's asking for grams, so we're just going to have to multiply by the molar mass of that. Okay, so silver is 107.87, and then you've got a nitrogen is 14, and then 3 oxygens, so 16 times 3 is 169.87. Okay, so let me not forget to shift back. Okay, so you multiply those out, and you get 5.73 grams. Okay. Now, maybe the most complicated question, or I don't know, maybe most time-consuming question on the exam, limiting reagent question: how many grams of the excess reagent is left over? Okay, and so we've got 6.00 grams of that guy and 10.0 grams of this one. Okay, so we have to do moles of each. So carbon disulfide, CS2, sulfur is 32.06, and you have 2 of them, and then 12.01 for carbon. So that's 76.13. So the moles, you have 6 divided by that, gives you 0.0788 moles of CS2. Okay, and then the other one is chlorine. So that's 35.45 times 2, so that's 70.9. And so 10 divided by that gives you 0.141 moles of Cl2. Okay, so now you want to just make sure the equation is balanced, and it is properly, yeah. And so again, you can't directly compare these numbers. You have to divide this one by 3. Okay, and so let's do that. So divided by 3 gives you 0.0470 moles. Okay, so now this is smaller, and so that means that this is the limiting reagent. Okay, so it's really in this question not asking about any of the products, it's just asking, so okay, this is now in excess, how much is left over? And so all you really need to do is, now we have a mole per mole basis here, let's just subtract them. Okay, so we have 0.0788 minus 0.0487. So that gives you 0.0318 moles are left. Okay, and it's asking grams, so we have to multiply by its molar mass. So that's the 76.13. Okay, and that gives you 2.42 grams. Okay, so times 76.13, the molar mass of CS2. Okay, and that gives you that. Okay, so you just subtract. So if you want to know what is left, you just subtract the one that is in excess minus the limiting reagent moles. Okay, and that's where I got, if I can do a long arrow, that one. Okay, so that's how many moles were left over. Okay, this one, how many moles of boron trichloride are needed for HCl? Okay, so again, double check if it's balanced, and it is. And so 25 grams of HCl. Okay, and then we want to know this one. Okay, so we can do the moles for HCl, so that is going to be 36.45. So 25 divided by 36.45 is 0.686 moles of HCl. Okay, and so we are interested in moles of boron trichloride. And so for this, we have to multiply by 1, divide by 3. Okay, or divide by, so you multiply by 1/3, or you divide by 3. Okay, so you get the same answer either way. So that gives us then 0.229 moles of BCl3. Okay, so after we divided the moles of HCl by 3. And so now, oh, I guess that's it. It's not even asking for grams, so that is the answer. Okay. How many oxygen atoms are there in so many grams of carbon dioxide? Okay, so note that there will be 2 oxygen atoms for every one of these CO2 molecules, right? So we'll have to take that into account a bit later. So we first have to, how many, again, means Avogadro's number, but our first stop will be to calculate moles. And so we have 52.06 grams. Then we divide by the molar mass of this. And so that's 16 times 2 and another 12.01. So that's 44.01 grams per mole. So 52.06 divided by that gives you 1.183 moles of CO2. Okay, then let's multiply by Avogadro. So that is 7.12 times 10 to the 23rd. Okay, this is how many CO2 molecules you have. Okay, but there are 2 oxygen atoms for every molecule, so you have to multiply it by 2. Okay, and that's where we get the 1.424 times 10 to the 24th. Okay, this one, percent yield calculation. Double check if it's balanced, and this one is. Okay, so we have 119.3 grams actual yield, so that's what you actually made, from the reaction of 61.3 grams of that. And then you have just excess of PCl3. Okay, so we're going to use this and calculate moles. So 61.3 grams divided by Cl2, so that's 35.45 times 2. So 70.9 is its molar mass. So if you do that, you get 0.865 moles of chlorine. Okay, and in this case, it's a 1-to-1 reaction, so therefore, you have 0.865 moles of PCl5, okay, your product. And so let's figure out how many grams you should have made. So for that, we just multiply by the molar mass of this. Okay, so phosphorus is 30.974, and then we've got 35.45 times 5. So that is 208.224 grams per mole. Okay, so if you multiply that times 0.865, that gives you 180.1 grams, and that's our theoretical yield. So we should have made 180.1 grams, but we only made 119. So percent yield then is just what you actually made over what you should have made times 100%. Okay, so 119.3 divided by that gives you 66.2%. Okay, which is that one. All right, this is nitrogen reacts with hydrogen to give you ammonia. Okay, so again, these are diatomic molecules. So we have to balance this one. So you have a 2 there for nitrogens, then you need a 3 there. Okay, and so we have 3.41 grams of nitrogen and 2.79 grams of hydrogen. So let's figure out which is limiting. So nitrogen, the molar mass is 14. So for nitrogen, you have 3.41 grams divided by 28, because you have 2 nitrogen atoms. So 3.41 divided by 28 gives you 0.122 moles. And then hydrogen, we have 2.79 divided by 2. Because again, you have 2 hydrogen atoms per molecule. So 2.79 divided by 2 gives you 1.395 moles. Okay, and so we have to divide the hydrogen by 3 and then compare. I think you can see that it's still going to be bigger than the other one. So you get 0.465, which is still larger than the other one. So that means nitrogen is the limiting reagent. Okay, so right away you can say nope, nope, and nope. Okay, so it really boils down between these two. So now let's figure out which is, or how many grams of ammonia you're producing. And so we said nitrogen is the limiting reagent, and so we're going to use this number of moles. Okay, and so nitrogen to ammonia is a 1 to 2, so we're going to have to multiply by 2. And so moles of NH3 is the moles of nitrogen gas times 2. So that's 0.244 moles of ammonia. Okay, and then you just multiply by its molar mass, which is 17 grams per mole. And you get 4.14 grams. Okay, so now that is the right answer. Okay, that gave the wrong one. Okay. Finally, no calculation. So if aqueous solutions of those are mixed, which precipitate is formed? So this is going to give you NaCl, they're going to swap partners, and then a barium carbonate. And so if you look at your solubility rules table, that is your insoluble salt. This is going to be soluble. This one, the spectator ions. So let's do the total ionic equation for this. So it's going to be Ag plus NO3 minus plus this one gives you AgI, so it's a solid, so you don't break that apart, but then you do break apart the nitric acid. Okay, so that's the total ionic equation. Spectator ions are the ones that are canceled. They're on both sides, so H plus and NO3. Okay. This is just a definition, so moles per liter is capital M, so this is molarity is capital M. The balanced reaction, so this is in words, so nitric acid and strontium hydroxide. Okay, so strontium, remember, is in group 2, so you need 2 hydroxides. And then in this one, you're going to form strontium nitrate and water. Okay, so then we're going to balance this here. So we need a 2 there for the nitrates, and then a 2 for the water. Okay, so that is this one up here. Sulfurous acids is just a definition. Remember, sulfuric is this. The "us" suffix means just one less oxygen. Okay. The empirical formula is simplest whole number ratio of atoms. So yes, it is. That's just the definition of empirical. This one, another limiting reagent. So you have 15 grams of that and 15 for oxygen. Okay, and you yield 8.70 grams actual for your NO. Okay, so what's the percent yield? So you're double checking, make sure it's balanced, and it is. And so now let's do moles for each of the reactants. So that is 15 grams divided by 17 grams per mole. So it's 14 for nitrogen, and each hydrogen is 1. Okay, so that's 15 divided by 17 gives you 0.882 moles. Okay, and then moles of oxygen is we've got, again, 15 grams divided by 32 because you have 2 oxygen atoms. So 15 divided by 32, that gives you 0.469 moles. Okay, so now let's divide by each by their coefficients and then compare. So ammonia we divide by 4, oxygen we divide by 5. Okay, so 0.882 divided by 4 is 0.221, and then 0.469 divided by 5, we get 0.094. Okay, so this is smaller, oxygen's smaller, so that means that's the limiting reagent. Okay, so we use this number of moles, okay, for oxygen to do the conversion to the product we're interested in. Okay, so if we want moles of product, we are going to have to multiply by 4, divide by 5. Okay, so that is 0.469 times 4 divided by 5 gives you 0.3752 moles. Okay, and so we have to figure out the grams, so let's multiply by the molar mass. So that's 16 and 14 is 30. So that gives you 11.256 grams that are theoretically possible. Okay, but you only made 8.7. So the percent yield then is what you made divided by what you should have made. So 8.7, and that's 77.3%. Okay. Net ionic equation between sulfuric acid and sodium hydroxide. So you're going to get sodium sulfate and water. So this is your molecular equation. Now let's break apart everything with an 8. Well, actually, let's balance it first, right? Oh, it's messed up there. So you need a 2 for the sodium, and then you're going to have 2 waters being produced. Okay, so now let's break apart everything with a AQ. So we're going to have 2 H pluses plus a sulfate goes to 2 sodiums, 2 hydroxides, then you're going to have 2 sodium, a sulfate, and 2 waters. Okay? And so now we can cancel the sulfate, and we can cancel the sodiums. And so what you end up with is 2H plus 2OH minus gives you 2 waters. Okay, that's not one of the answers, but if you'll notice, if you divide everything through by 2, that is an answer. Okay, so that is the simplest form of the net ionic. Okay, so whenever you have an overall reaction, you can divide everything through by an integer, non-one integer. You should do that, and that is the simplest version of the equation. Okay, spectator ion is always included in the net ionic. No, it isn't. Right? The spectator ions we canceled, right? So they don't appear in this. So that's a false statement. The coefficients, so we balance this one. So we've got carbons are balanced. I would do hydrogen next. So we have 4 on the reactant side, so let's do 2 there. So now oxygens, we have 3 on this side. No, we don't. If I could only count, right? Okay, whoops. Okay, so we have that. So we have 4. Yeah, that's right. So we have 4 oxygens on this side. Okay, and so this side right now we only have 3. Okay, and so what you really need is, if we have 1 here, we really need an additional 3. So let's do this, like 3 halves there. Okay, and so 3 halves times 2 gives you just 3, right? So now you've got 3 and 1 gives you 4 on the reactant side. Okay, so to get rid of this fraction, you multiply everything through by 2. So it'll give you 2 plus 3 oxygens gives you 2 CO2s and 4 waters. Okay, so in other words, that one you're multiplying by 2. Okay, and it's asking, after all that, what's the coefficient of oxygen? It's 3. Okay. Empirical formula. So we assume we have 100 grams of sample, and so 81 grams of fluorine and 19 grams of carbon. So then we divide by their atomic masses. So this we can round to 19, and then this we can round to 12. Okay, so 81 divided by 19 is 4.26 moles, and then 19 divided by 12 is 1.58 moles. Okay, then we divide by the smallest one. So this, of course, is 1, and then that is 2.69. So really, this is saying that we have CF 2.69. Okay, but we have to get these to integer ratios, whole number ratios. And so this number is pretty close to like 2.66. Okay, so let's multiply both by 3. Okay, so both by 3 will give you C3F. So we do 2.69 times 3. That is 8.08, which is pretty well 8. Okay, so C3F8 is the empirical formula. Okay. If you, actually, if I mention this, if you thought that this maybe was closest to 2.75, And then, multiplied by 4, 2.69 times 4, you get 10.75, so it wouldn't work out, close to an integer value. So multiplying by 3 gave a number closest to a whole number. What's the mass for a single chlorine molecule? So remember, it's that, okay? A chlorine atom is that. Okay, so molecule tells you it's Cl2. And so if we have one molecule, we divide by Avogadro's number, and that will give you the moles. So 1 divided by 6.02 e to the 23rd. 1.66 times 10. Whoops, there we go. 10 to the minus 24 moles. Okay, and then it's asking for mass. So we just multiply by the mass, the molar mass of Cl2, 35.45 times 2, so 70.9. So that's 1.18 times 10 to the minus 22 grams. Okay, so in a question like this, a single molecule is going to be insanely small. So you can right away say those are wrong. Okay, so it kind of boils down to these very, very small exponent answers. The molar concentration of sulfate ions. Okay, so if we have Na2SO4 in solution, it'll give you this. Once it's dissolved. And so whatever concentration you have here, it is a 1-to-1 relationship with the sulfate ions, right? So you have the same concentration, so 0.150 moles per liter for sulfate. Okay, if it were asking for sodium, then you'd have to multiply by 2. Okay, so it's just the 0.150. The molar mass of calcium permanganate. So calcium is this, permanganate is that. So it's really MnO4 2. Okay, so if we look in the periodic table, calcium 40.078, then we have manganese 54.938, and you have 2 of them. And then you have 16 times 8 oxygens. So that's a grand total of 277.95 grams per mole, or 278 rounded. Oops, there you go. Okay, and now balancing again. So I would do phosphorus first, then I would do hydrogen. So we've got 12, so you need a 6 there. And then oxygen, we have 16, so you need an 8 there. Okay, and then assuming that's 1. Okay, if you just add these up, so you have 12, 13, and then another 6 is 19. When these are mixed, the precipitate forms. Okay, so this reaction, you're going to get sodium bromide and potassium iodide when they swap partners. Both are soluble. Okay, so they're group 1 compounds. So in your solubility rules, that predicts their solubility. And this one, you're going to get lithium iodide and then cesium carbonate. Cesium carbonate. Yeah, it is actually like that. Okay, again, these in your solubility rules, those are soluble. These ones, it's potassium chloride and then chromium 3 sulfate. What's that? That, okay. And again, these are both going to be soluble. This one you're going to get nickel 2 nitrate and silver bromide. So now you have one in your solubility table that says that that is going to precipitate. That's not soluble. Okay. And then this one you're going to have potassium nitrate and barium hydroxide. Okay, again, both of those are soluble. Okay. Which is a weak acid, so that one, it goes back to what we talked about in question 1 there. It's not one of those 6, so you assume it's weak. And then which is an empirical formula. So this one we can divide by 2 to give you NH, whoops, that was weird, NH2. Okay, so that's not empirical, that's molecular. This you can divide by also 2 to give you P2O5. So that's not empirical. This you can divide by 2 to give you CF3. Okay, this one you can't divide by anything, where you divide everything through by that same factor. So that means this is empirical. Okay, so I hope that helps. Let me know if you have any additional questions, and take care.